Hello, everyone. Welcome. Thank you for joining me today. My name is Sahdev Zala. I am a senior software engineer at IBM and working on open source development for about 10 years now. I work on many different projects in this journey. Currently, I am contributing to Kubernetes, which is a cloud native project under Cloud Native Computing Foundation, which is under Linux Foundation. I'm also a maintainer for the HCD project. And for that, I'm wearing hoodie today. It's a data store for Kubernetes and a critical component of Kubernetes. So let's talk about open source and the security, right? So many people ask me this question, and if you are new to open source, you may have the same question. I'm not going into detail here because this is a broader topic and with the time constraint, but briefly, the answer to this question is open source software secure, right? It depends on the project, the maturity of the project. Can you hear me, by the way? It's good? Okay. So it depends on the project, right? Is it a project which is just around for some time? Is it something just came out yesterday, right? Who are the adopters of the project? The community behind it, right? You want to make sure that is it the project, maybe just one developer or two developers are, working on it, or is there a dynamic community behind it? How good is the project being maintained, right? Who are the maintainers? How active they are? How much importance or seriously they are looking after the security, right? And more importantly, the governance, the open governance behind the open source project. So for example, I put this quote from Jim from Linux Foundation. Linux Foundation, they take open source project security, the code security real seriously, okay? And I'm going to mention one of the other initiatives they have, OpenSSF, Open Source Security, Software Security Federations. So the governance is important. I also want to mention here that, having the code open, right? People can take a look. That's actually a good thing. Because a lot of issues, especially when there is a good community behind it, the issues get caught early, right? Because, all of you, myself, many others involved in the project, you have the code, you're looking at the code, you're giving it a shot, right? You find issues, you report it, and they get fixed early in the development cycle versus, the proprietary code where it's only the, certain people has a privilege to look at it. Let's talk about the real thing here, right? The coding practices, and the next slide, I'm giving a security checklist. But so, the first and foremost, right? You want to know and identify what are the high risk areas in your project, right? Whether you are contributing, you are a maintainer, you're just checking it. If you're curious about security, right? Well, how do you find out what's most important from security perspective? Well, look at the project architecture, right? That tells you what are the areas that you should look, right? And consider for the next step, which is the secure code review. Now we know that code review, it's an ongoing process, right? It's part of your development cycle. Each and every PR, the pull request that got merged, should be reviewed seriously. And in most good projects, they are reviewed seriously by the maintainers, right? Making sure that the code which is going in is it's good. But at some point, typically at the end of the development cycle, you want to do a like official or more formal code review, okay? And that's the point where most of the functionalities for the projects are already in. You have a good picture of overall, the project, and that's the time you want to do a like formal secure code review. We know that manually you're not going to go line by line. I mean, of course you should, but depending on the project side, that's difficult. And we know that there are a lot of automated tools out there that helps find issues, right? So definitely you want to do the automated review. I'll show in the next couple of slides. Manual reviews, right? There's no alternative to it. Definitely you wanna, check the results of the automated findings, look at the code yourself. And like I said, it's more formal. So you have like a team of people, doing this secure code review, and everyone has that like a role, what they're focusing on it, right? So it's easier, it's more efficient. Um, if it's possible, third-party security audit is highly recommended. For many projects before actually they declare themselves as a mature project, production grade, production ready project. They require to have a third-party security review. Okay, so that unbiased findings come out and fixed. And then a plan for to address your findings, right? Short term, longer term. There are issues you may find out which will take like longer. You're like, hey, this is not something that we can fix it in a day or week or month, right? But in that case, do whatever you can to do it, address short time, right? Whatever workarounds you have, documentation for that workaround. And then, CVEs, right? Make sure you plan on publishing the CVUs based on your findings. That's for your stakeholders of your project, right? So you need to have that plan as well. So for the secure code reviews, right? I mean, this is very important. What are the things that you should be paying attention, right? So the first two here in the list, authentication and authorization and TLS certificates, right? Together, we know that they provide solid security. And those two areas are typically, well taken, right, by the developers, because they know that that's important, right? But then some of the other areas I mentioned here, they get ignored many times by the developers, unknowingly, right? Many times they're not well educated. Many times, it just doesn't come up, right? I mean, like I said, the first two, it's like, okay, those are definitely related to securities, right? But then, data validations, that's a key, right? So you want to validate every single input, okay, no matter what. And then, what's the expected data type there, the length, range, whatever you can. Make sure that whatever you're getting is something expected. You're not sort of processing something which is not unexpected and run into problem. File permissions, of course, which it's an important area. I'll provide an example a little bit later in the talk. But if you're using third-party tools, the third-party libraries, right, packages out there, they're great, but it's your responsibility that you make sure whatever functions you're calling, if any APIs, they are secure, right? Don't just always think that, oh, it's from third party, from the Golang packages, it's good, I don't need to worry about it, right? Logging is very important. Make sure that you log any errors that can provide a security alert. And the same time, error handling, right? That is another key things, that you handle errors, and at the same time you make sure that you don't leak any sensitive information, right? That has been a case in many times, even you see it in sort of news, right? That part of the error, somebody has exposed the password, right? Or some other sensitive information. So you definitely want to make sure that you're taking care of it. And then third-party tools, like I said, whatever tools you are using, make sure they are compliant, right? Use the latest releases as possible. Keep eyes on what are the CVEs that those tools has published, those projects, right? The other open source projects you are using, right? And make sure you are sort of considering that while using the tools. The last one, documentation and configurations, right? It was like, what's up with the documentation and security, right? Or configuration, right? But that's another area. Documentation is important. It especially is key while doing this secure code review, right? It helps the team to navigate the code, right? So documentation, like, not just the comments, right? But the function naming, right? There are functions that are like misleading names, and that can create confusions, right? Configuration. So, make, any like things, for example, if your project out of box, if you want to make it insecure, because having it secure, TLS certificates and all that can take time, and you want your users to use the project real quick, so you want like, oh, it's by default it's insecure, but you can, you have the security options, so make that configurable, make it secure by default, and then have them, set the flag themselves, that they know that it is insecure, it's their responsibility, that they take care of it later. All right, so what are some of the things that, tools and manual efforts that you want to keep in mind, right, as part of your secure code review? As I mentioned, there are so many tools, out there, no matter, what programming languages your project is using, right? Golang, Java, whatever, right? But identify what tools are out there. I provided a few examples here for the Golang. So like, GoWait, for example, right? More like a static analyzer, finding the, doing the static analysis for your code. And then, we know that there are dynamic tools out there like fuzzers, right? So again, like say, find out what's right for you, use them. Okay. And then manual reviews, right? Like, I said, the automated tools, they are great and everyone should use it, but they don't know the context of your code. It's a human who understand like what context this code has been written for. So verify the output of all these tools, make sure that whatever findings came out of this automated testing or review is appropriate. It's needed. Okay. All right, so I'm just giving a couple, quick examples here, considering the time constraint we have with the talk. But a simple example here, right? Like I mentioned earlier, file permissions, right? Or access related things here. So this is a little snippet in Golang. Very simple. All it does is it's calling this, is using that OS package and calling this make.dir all function, right? And basically you want to create that directory with the given 700 permission. And if there is any error from the function, you returning error and you handling the error. Okay. But if there is no error, then you are continuing your flow. So what's wrong here? This is actually a real example, which was found in the third-party security audit, like by professionals, right? So this kind of things get ignored easily, right? Well, the problem here is this. So what happens, whatever the path you have provided, if that directory already exists, then the make.dir all function, it does not return an error. It's like, okay, it's there, I'm good. Doesn't do anything, right? It just returns nil. What if that directory has a different file permission than what you expecting, right? What if it's like 777? Well, you don't know that, right? So like it's a small thing, but that can be a security issue. Some hackers can do that and get an undesired permission on your install and on your code. So in this case, the fix was very simple, right? You just make sure that you're checking for that directory. If it exists, then check if it has the desired permission. If it's not, then that's an error case. Okay, you don't go forward, right? The second thing here is data validation, right? So it's important. Again, this one is using another package, string conversion, right? The function toy basically takes a string value and gives you integer. Okay. And then, based on that, it's basically the time value that you are expecting in this function. And then you have some logic to, update the log to that given interval of the time. Again, it looks okay. This was again, like part of the, findings from the third party. So this is real example, not something that I made. So what's the problem here, right? It seems like it looks okay. It looks okay to me. It's working. There's nothing wrong in when you just take a look. But the problem is the string conversion function here. It can return negative value, and that's not an error case. But you're not validating that input, whether it's negative or not. And in that case, I mean, that update log function can flood your log based on that negative value and, fill out all your disk space. And at one point it will break your application. Okay. Small fix again here, right? You're just checking for the negative value and you are good to go. Okay. The other thing I mentioned earlier is the CVEs, right? This common vulnerabilities and exposures. There are list of publicly disclosed security flows, and the the IT folks, they use it to understand the flow, the vulnerabilities out there, and take necessary measures, right? Updating their version or some workaround, or even security researchers, they look at what's out there, right? And it's the Maitre Corporation, they usually handles this CVEs for for all kind of CVEs. So I want to mention here that nowadays many projects, I mean, they are on GitHub, right? If I learned this while I was leading one of the security audit myself, and I was creating some CVEs for the project, and that time I learned just recently that GitHub has integrated way of um, working on the advisories, within your small team of maintainers. You can do it like a, there's a security advisories tab on the GitHub. You will see it if you are one of the maintainer, if you have access to the project, okay, the right access, right? Otherwise you don't. But as a maintainer, you can just go to this tab, you use that new draft security advisor, you create one, and you put whatever descriptions you have, and then you work within your private maintainers group. And then it takes things like the kind of vulnerabilities and the workaround, whatnot, those are used to publish the CVEs to the external world. But it's very handy, and I like it. I mean, this way you can keep everything under your project. Okay. With the time considered, I know a little bit more than 50 minutes. I'm taking that extra few minutes here, but we are already at the 50 minutes. So I would conclude as like, the secure coding is challenging, right? It's not just so easy, but it's possible. You can have a project with minimal possible vulnerabilities, right? So the key things here are, understand the project architecture, understand those high security areas, secure code review. That's the key. You definitely want to do it. Use those tools, manual reviews, right? The other thing is less popular features. Many time, those are the source of security problems because they are less popular. Developers, they're not like, there are not many requirements on those, and something out there which is overlooked, right? So, keep eye on that. Use third-party audit as it's possible. And, of course, take consideration of publishing CVEs, right? This is good. I mean, if you are interested, I like all this learning resources here. Open source at IBM, you will get everything that how we do open source, right? And it's just not at IBM. There are tons of material there, lots of blog posts, a lot of other materials you may want to take a look. But then the RISC-V, the Open Web Application Security Project, great material, tons of good material about security, software security, right? It's open project. Open Source Security Federation, that's a federation or foundation under Linux Foundation. Again, lots of good material there. Maitre Corporation, as I mentioned, they handle the CVEs and they have all kind of material for the security, software security. Trail of Bits blog, that's the one of the independent company I work with, for the audit, and they have lots of good material, a lot of good learning for myself there. With that, thank you so much. We can take question now, or reach out to me, after the session, and I'll be, happy to connect with you and, discuss anything that you would like to. Thank you so much.